All right. What we're going to be doing today is looking at the blower transistor for the NSX. So we have the ETE 91 electrical troubleshooting manual here for looking at. Power all the time, goes to the blower relay. Anytime the ignition is on, it closes this relay, provides power to the blower motor circuit. And then it also provides power to the side of the blower high relay. The blower motor is in the middle here. You got a junction connector that lands, looks like 3 different wires, 1, 2, 3, 4 different connections. So the CCU gets a feedback from the bottom side, from the point between the transistor and the motor. So it is a feedback controlled circuit. It is an analog circuit, it's not a PWM. Signal out of the climate control unit, which is an analog signal, goes to the base of the power transistor. The emitter of the power transistor is connected to ground. And of course the collector here on the transistor is connected to the bottom of the motor, so it is ground sites controlled. The other part of the circuit, this is it's showing a standard transistor. It is a Darlington. There is also a thermal fuse inside the package that most commonly fails if it draws too much current because of a bad blower motor. So this is for speed control. The transistor does speed control. When you go all the way to minimum or maximum temperature, or you turn the fan control to max, it closes the blower high relay, which bypasses all of this. If you notice, it switches the ground over and brings the ground to the bottom of the blower motor. So the blower, most climate control failures, you'll lose speed control. There's the climate control unit here. You'll lose speed control, but you won't. It should still run on high. It's uncommon that it won't run. So I'm going to go over testing this power transistor. It's obviously a 3-wire device, white, blue, black wires coming off of it. It's just positioned on the side of the blower housing. I believe you got to remove the blower housing to get to it because the coolant pipes are in the way. But on the right-hand drive it might be different. But so I got a little test fixture set up here. Let me pause and get that in the screen, and we'll go over that. Go over the testing of it, or the operation of it. All right, so here we are here. Swing the camera over a bit. All right, so here we have a blower motor transistor. This is the way it looks in the back. This is what you see. This is in the airstream to provide cooling for the transistor. Definitely a used one. It's kind of dirty. Here we have the blue, black, and what they call a white wire coming into the connector. And blue is the top side of the transistor, which here I have it run over to this red wire with a 1/4 inch fast on just for testing. And this is my blower motor. The 3 light bulbs in series, just to give me a visual indication. The black wire is the negative side. Here goes to ground. So power comes in, goes through the blower. Power comes in, goes through the blower motor, goes to the transistor. Transistor controls the current, so to adjust the speed of the blower motor. Climate control provides output to the transistor. The climate control also monitors the voltage at the top of the transistor, so it can control how fast the motor runs. So it does have an analog feedback circuit. So, like I said, negative. So this is 12 volt positive. It's got a 12 volt power supply just off this corner there. Negative goes right to the black. And then the white wire here. I have it connected to a jumper lead and a 2.2K resistor. You can't, you don't want to apply voltage, apply a signal directly off of the positive rail. You'll blow the base emitter out of it. You'll damage the transistors. So I think the service manual says you're looking for, at full speed, you're looking for about 2.3 volts at the white wire. So that's a good way to check for signal from the climate control unit, is to check the white wire for 2.3 volts. So we power this up. We got our 12 volts on, and you can see the lights are out, so the blower motor is not running. So if I apply positive voltage to the base on the white wire through this resistor, just to protect it, current limit, it turns on. It's the Darlington transistor, so it's surprisingly sensitive. Doesn't take much current to control a large current, so it has really high gain. So that's the essential operation. Like I said, you know, of the circuit. It's pretty simple. There is, like I said, a thermal fuse potted inside of here. So if the blower motor draws too much current, it will blow that thermal fuse, and it's not a resettable thing. When it goes, it goes. So that's the main problem with the main failure point on these. They're not really repairable, and unless you want to dig out all the stuff, all the potting and stuff, and not really worth it. Like I said, if there's any questions about it being good or bad, you can bench test it like this, or like I said, just monitor the voltage at the white wire as you go through the cycle through the speeds of the, go up and down in speed of the climate control, and you'll see the voltage level on the white wire go up and down. And like I said, I think the service manual, there's a test procedure in the service manual for checking that voltage to make sure you have power. If you got power in the white wire, and obviously you got power on the blue wire, and if the motor's not running, and the motor's bad, or the transistor's blown out, you can obviously check that this blue side of the thing gets pulled down as this powers up. But like I said, they do fail. If you do have one that's failed, definitely you're gonna have to check the blower motor, because it's probably what caused it to fail. So I don't know what these are list, but I think they're $250 or so on the parts website. So all right, that's about it. Let's make sure it's still working. All right, let me pause. I'm gonna hook up another one. I have a second one here. I want to just test and see if it's good. This was off my test fixture, so it's a working example. Test good, and it runs on my test fixture. So let me hook up another one here and see if that one's good or bad. All right, so I hooked up another one from in the bin. Don't know if it's good or bad. I am getting a little bit of glow on these lights when they're off, so I'm not sure what that's all about. And this one definitely does not work. So this is a defective unit. So yeah, that's applying power to the white wire through a 2.2K resistor, and we got nothing. So this one is going to get the bad. I think I got it from somebody. I was going to try and repair it, but definitely not. By the time you Dremel out all this stuff and get in there and take it all apart and replace the thermal fuse, might as well just buy a new one. So, all right, that'll do it.